So you guys really liked that last video where I showed you how easy it is to design your own PCBs. You click that comment there if you haven't seen it yet. So today we're going to dive a little bit deeper and learn about PCB layers. Once you understand this concept, you're going to be able to design crazy complex PCBs all with free software. And as always, I'm going to break it down in really simple terms so it's super easy to understand. Let's dive into it. So refresher, in the last video I showed you guys how to get up and running on KiCad, which is a free software, and we built this little circuit where we have a USB that has a trace that goes to a little button, which then goes to an LED and then closes the circuit. Which makes this really simple PCB. We have the USB port that can be soldered here. You see the trace going to the button, to the LED, and then back to the USB port. Now, that's all fine and dandy, but when you start making more complex PCBs like this one, the traces become kind of overwhelming. You can see here the red lines and blue lines are absolutely everywhere. And it's not as simple as just running a wire from this pin to this pin, because you'd have to go through all of these other ones. But luckily, there's a way to solve that problem. To help demonstrate this, I've designed this super simple PCB. You see, we have these two pin headers here, and the intention is to connect all of the pins across from each other here. And you can see we've done that with simple traces. If we wanted to connect these two pin headers, however, we're kind of out of luck, because if we were to run a trace, a wire across here, it would intersect with this one and cause a short circuit. So what's really cool about PCBs is there are two different sides that we could run traces on. You'll see here, you can see all the traces on this PCB on the back side here, but you could also see that there's traces on the front. What we can do is we can run those traces on the back of the PCB. So here's our little PCB sketch here. You can see that we already have the traces running across here like we just saw in the 3D render. But you can see that it's wanting us to draw traces down here, like we said, to connect these two. Now, if we just grab our wire trace drawing tool and we try to draw from here down and connect the two, you'll see it won't let us because it's intersecting, and again, it would cause a short circuit. All we have to do here is go over on the side here, and these are all the different types of things you can draw. Don't worry about this big intimidating menu. What we're gonna do is click BCU. This stands for back circuit. Now check this out. When we go to connect these lines now, it's gonna show up as blue. This means it's on the other side of the circuit board, and we can now connect these. What I'm gonna do is connect all of these, and I'll show you what it looks like in the 3D render afterwards. Now check this out. We have our regular traces here on the top of the PCB like we had before, but if we spin this around, you can see that we have traces on the back. Because these are on different sides of the board, they're not going to interfere with each other at all, and this lets you route a whole bunch of traces on a board a lot more cleanly. But there's an even better way to do this. So let's say we have components like these resistors here. The thing about these resistors is you could only solder them on this side of the board. They don't have a hole that goes through the back, so we couldn't actually run a trace through the back here. You might think that we're forced to figure out how to do it on this top side of the board, but that's not true. So what we're gonna do here is grab our trace tool again, and we're gonna draw on the top of the PCB. With our red wire here, this is on the top, so we will be interfering when we try to go through here. But instead of drilling on the back, what we're gonna do is push the V button on our keyboard. This is gonna drill something called a via. This is basically gonna let us jump over temporarily to the other side of the PCB, and then once we get over to the other side, we could simply press V again, and then when we do that, we'll drill another hole, and then come back out on the top. I'm gonna do that for both the connections here. So check this out. This is the top side of our PCB. You'll see we have our resistors here, and there is a trace going over to where we'd normally need to cross over. But it jumps down to the bottom of the board, hops over that set of wires, and then resurfaces on the front. So we can still have these top mounted components without having to interfere with all these traces. I use these in plenty on my InfoOrbs PCB. They're very subtle in real life. They don't look like big holes. You can see these little dots here where the PCB is terminated. Those are all vias that allow me to jump over all these traces and run them across the back of the board. Now, this rabbit hole goes a lot deeper, but understanding the basic idea of vias and different layers of the PCB is going to unlock so many different things for you and allow you to make really compact boards. Now, when you want to start making super compact boards, take something like a Raspberry Pi here with a ton of components. It doesn't actually stop at just 2 layers. There's PCBs that are 6, 7, 8, 9 layers that are pretty much the same idea of having just the front and the back, but it's a whole bunch of PCBs sandwiched together. That lets you run through a lot of different layers and have a bunch of different levels that you could jump over traces on, which lets you basically make something super compact like this. But that's kind of out of scope of this. For a lot of hobby projects, 2 layers is going to be all you need. I've been really enjoying learning about PCB design and sharing it with you guys. If you have any questions or suggestions, please let me know in the comments. Thank you guys for watching, and I'll catch you guys in the next video.